Hello everyone, welcome back to the Java tutorial series. In this video, we will learn about HashMap in Java. By the end of this video, you will understand what a HashMap is, how it stores data, its internal working, important methods, and advantages, limitations, and also we will see practical examples. Okay, so let's get started. So what is HashMap? So HashMap is one of the most commonly used collections in Java. So HashMap is what? HashMap is the implementation class of map interface. So we know the hierarchy, right? So map is the interface. It has implementation classes. Implementation classes. What are those implementation classes? So HashMap, then linked HashMap, then tree map, then concurrent HashMap. So these are the implementation classes. So as part of this video, we are covering one of the implementation class of map, that is HashMap. Okay, so we know the property of map. So whenever we want to store the data in the form of key and value pair, we go for map, correct? But map has several implementation classes. How we will choose which one to use? So for that, we should be knowing the properties, the features of each implementation class. On the basis of that, we can select, okay, this implementation class we should choose. So let's have a look, or what are the properties for HashMap. So HashMap stores data as a key and value pair. Every key must be unique. Key cannot be duplicate, but values can be duplicated. So it can have, like, multiple keys can have same values. That means values can be duplicated. And HashMap is a part of Java collection framework. It is a part of Java collection framework, but it does not belong to collection interface hierarchy. So there is a iterable, then collection, then list, and then set, and then queue. So map does not belong to this hierarchy, this iterable, collection. This hierarchy does not belong. HashMap belongs to hierarchy of map interface. It has its own hierarchy, which is different from collection interface. But map is a part of Java collection framework. So HashMap is also a part of Java collections framework. And HashMap is what? HashMap is the implementation class. That's why it implements the map interface. Okay, so it stores data in key value pairs. Every key is unique and is used to retrieve its corresponding value quickly. Okay, so why I said quickly? Because HashMap follows hashing algorithm, and hashing we know, hash code and equals method, internally how it works. So that's why it find out the value quickly. Okay, now let's look at the Java collection framework hierarchy. So we have iterable is the parent interface, then collection is the child interface. So this interface has child interface, list, set, but map is not part of collection. Okay, map is not part of collection. Map has its own hierarchy. It does not belong to collection. Only list and set belongs to collection. and we have seen the implementation classes of the list and the set. So map is different hierarchy and it has different implementation classes. So in this diagram, there are two implementation classes, HashMap and TreeMap. Okay. We have linked HashMap, concurrent HashMap. So these are the implementation classes of the map interface. Okay. So map stores data as key value pairs instead of individual elements. That is the reason the hierarchy of map is different. Okay. Because in list and set we are having only one individual value, whereas in map we have the key and value pair. That's why hierarchy is also different for map. Okay. Now let's look at some of the features of HashMap. Okay, so HashMap will store data in the form of key and value pair. Key will be always unique, but value can be duplicates. Okay, only one null key is allowed. So let's say this is the bucket, and in each bucket we have what? Entries. Okay, entry 1, entry 2, entry 3, entry 4, entry 5, and entry 6. Entry means what? Entry means key and value pair. Okay. So each entry will be stored in the bucket index, in the each bucket. Okay. There are different indexes. And let's say we have multiple entries in the same bucket, then that will be stored in the form of linked list. We know this thing, right? So here it is saying only one null key is allowed. We can, in the entry, in the key and value pair, only one null key is allowed. We cannot have more than one null key. Okay. But values we can have null, multiple nulls. Okay. Values we can have null, multiple nulls. So multiple null values are allowed. And it is an unordered collection. Unordered means the order of insertion is not maintained. That means the order in which the elements are getting inserted, entries are getting inserted, is not remembered by the HashMap. Okay. So it is unordered collection. And it does not follow sorting also. So unordered, that means no ordering and no sorting. Okay. For HashMap. It is not synchronized. That means there is no inter-thread communication, no thread safety. That's why faster in performance. Okay, there is no inter-thread communication, so there is no extra work. So it will be faster in performance. Okay. That's why it is fast lookup operations. So HashMap, you always remember, it is faster in performance. Why faster? Because it is holding object in the key and value pair and it is not synchronized. Not synchronized means no inter-thread communication. That means faster in performance. Okay. So these are the features of HashMap we should remember. Okay. Now we will go to IntelliJ and have some examples so that we can have better clarity. Okay. So let's go to IntelliJ, and what we are learning today, HashMap. HashMap is what it is. It is implementation class of map interface. Okay. Now we will create an object of HashMap and we will see how different operations we can perform, and those features we'll see everything here. Okay. So let us create first an object of HashMap, and here in generics, in the list and set, we used to provide only one data type, but here we need to provide two data type, one for the key and another for the value. Why? Because map is stored in the form of key and value pair. So let's say I'm giving integer as the data type for key and string as the data type for value, and I'm giving the HashMap reference variable as students, okay, equal to new HashMap. So we created an object of HashMap with the key and value pair, with the key type is integer, whereas value type is string. Now in the HashMap, I will add some entries. How I will add entries? Students dot put. What do I mean by entry? Entry means key and value pair. So map means, always remember, whenever we are adding something, it will be in the form of key and value pair. Okay. So let's say I'm adding 101 is the key and the value wiki. So I added one element. Okay. So how it will work internally? It will work internally. So based on the key, it will try to find out hash code method will get execute, and it will find the hash value, and based on the hash value it will find the bucket, and inside that bucket it will store this entry key and value pair. Okay, now let's say I will add one more entry with the key and value pair. Okay, so 102 Rahul. Okay, and let me add one more 103 comma xyz, whatever. Okay, so we have added three entries, three students in the students HashMap. Students is the reference variable which is referring to HashMap object. Okay, and we have added three students, three entries. Okay, so which method we are using for adding an element? Put method, adding an entry. Okay, now we have added. Okay, but how we will see, how we will verify that those elements are added? So for that we need to retrieve the elements, get the elements. So we will write the print line, and let's say I want to get only with the 102 key. Okay, I want to get the value of key 102. So I will use students dot get, and inside get I will provide the value of key, that is 102. So what should I get? So how it will work internally in this line? So what it will do means, we have provided key, right, 102. So what it will do in this line, with the key value, it will first find the hash value by executing hash code method. Then after finding hash value, it will go to the appropriate bucket. Okay, and let's say in this case we are not having multiple values in the same bucket. Okay, so after finding out the bucket, it will execute equals method and it will find the value. So it will return the value, that is Rahul. Let's verify it. So the get method retrieves the value associated with the given key. In the output you can see Rahul. Okay, now let's say if you want to update the value, instead of Rahul I want to update the value to something else. How we will do that thing? So for updating also we can use the same method, that is put. Okay, we have different methods, put if absent. Okay, put if absent. So I will use the same method 102, same key I am providing, but the updated value. Okay, I will write it as updated value. Okay, so we'll have so I have used the put method to update the value for the same key. Now if I run the get method, we should get the updated value. Let's verify it. See in the output. That means if a key already existing, the old value is replaced with the new value. Okay. So we have seen how to update the value. Now let me give the duplicate key. So we know the features of map, right? We cannot give the duplicate keys, but I am trying to give duplicate key and we will see what happens. Okay. So here I am giving something ABC. Okay. So here you can see, right, same key 101 we have already given with the value wiki, and now I am again giving with the value ABC. Okay, so what it will do, 101 key. So when the same key is inserted again, the previous value is overwritten. Okay, how? Let's verify it. So I will, instead of 102, now we are checking 101, I will make it 101 and we'll verify it. So the output should come as ABC. Why? Because we have redefined the same key, so it will overwrite. If we are providing duplicate keys, then the value will be get overwritten. Let's verify it. See, ABC. That means HashMap does not allow duplicate keys. Okay. And we know one more rule, that only one null key is allowed. What does it mean? Only one null key. That means we can keep the key as null only one time. Let's say null, comma, this is null value, null key value. Okay. So see, it is not throwing any compilation error. If I print here, let's say, how I will print. So let us try get null. So if it gives output, means it is supporting one null key value. So in the get method we provide key value, and the key value is null and the value is this one. So output is coming as this is null key value, that is value. Okay. And let's say I am trying to give one more null value. What will happen? Let's say this time I am giving hi. What will happen? So this value will get overwritten. Let's verify. See, hi. So value is overwritten. And also we have seen one feature that we can provide value as null any number of time. That is not required. See, for key we are trying for multiple null values, so the value is getting overwritten. We cannot see this old value, right? Because in HashMap, in map, only one null key is allowed. But values we can keep null as many as time. Okay. So I will update the existing ones only. So here we have seen, right, 101, 101, 2, 3. Okay, I will comment this out. Now I will keep this as null, 102 as null, and 103 as null. Okay. So values are null for more than one entry. Okay. So this is allowed in HashMap. Now let's say I want to remove the element. How we will remove the element? So there is one method called remove. Students dot remove. Remove, let's say 101. Okay. So 101 is removed. Only we are having 102 and 103. So the remove method deletes a key value pair using key. Likewise, we have different methods like students dot contains key. Contains key will return boolean value. Okay, contains key, let's say 101. So it will tell whether this key is available in the HashMap or not. And similarly, we have the method called containsValue. So it will return whether we have this value or not. And similarly, we have method students dot is empty. Is empty will return true if no element in the student, no entry in the students. Okay. Likewise, we can get the size of the students. So these are the common methods which are used. So we should know these methods. By name, it is clear what is the use case of this one. Okay. So HashMap provides useful utility methods. Okay. To check whether a key or value exists, whether the map is empty, and the total number of entries we have in the HashMap. Okay. Now, let's say I want to iterate through each values. So for that, I will write one for loop, and here we use map.entry. Okay, map.entry. And here I will use integer comma string. Okay. So this is what, instead of data type, we are providing map.entry, and here we will provide entry. And we have one method which will convert the key and value pair into the entry set. Entry set means the set of entries. Okay. So for each entry will be added into the one set. So we will be having set of entries, and here we have the built-in methods. We can directly use entry.get. Okay, it is not allowing import class. Entry.get. See, get key. Entry.get key plus space. So we are trying to print key and value. Okay, entry.get value. Okay. So these are the built-in methods provided by Java. We have to use it for our own use. Okay. So what we have done, how we write simple loop for and the data type and then variable name and the array, like that. Okay. So here what we have, instead of data type, what we have written map.entry. So entry we know, right? Entry means key and value pair, and we are using generic, so we need to provide the data type integer comma string, and entry is just a variable name. And here what we have done, students.entrySet. So students is what? Students is referring to the HashMap. So HashMap will contain key and value pair, that is entry. HashMap will contain entry. So there is a built-in method called entrySet. What it will give? It will give the set of entries. We know, right? Set of entries. We know collection set, right? Set of, if you are writing like set integer, okay, equals to new set of integer, whatever. If you are writing like this, so what do we call this one? Okay, you cannot provide a hash set. Okay, so we need to provide some variable, no? Okay, XYZ. So in this statement, we are using set, and the type is integer. That means it will carry, it will contains the value with the data type integer. So set of integer. So likewise, entrySet will give set of entry. Instead of integer, it will give entry. So that set of entry, then in this loop we are iterating through each entry, and through each entry we are printing using println, and each entry has the method for getting key as getKey and for getting value as getValue. So let's see the output. So we have three. I will comment this out. So we have three entries. Okay. So we are iterating through each entry. See, key and value, key and value, key and value. And here we can see multiple null values are allowed. That's why we are able to see here. So whenever we want to print the map, we need to use entrySet as the method to get the set of entries, and we are iterating through each entry. And for printing key and value, we are using methods getKey and getValue. Okay. If you write this code once or twice by yourself and try to understand what is happening, what each method is doing, you will understand better. By name it is clear. entrySet means whatever entries we are having. Entries means key and value pair. So it will return set of entries. So we are iterating through each entry and we are printing. Okay. So let's see the internal working of HashMap. Okay. So there is a contract, right? I told you contract. Contract of what? So we have two things, hash code and equals method. So these methods we should have. Okay, we should override. So how these two methods will get used? So we have in map, we store objects in the form of key and value pair. Okay. So when we have the key, so we will use this key for generating hash code. Okay. So we are using key for generating hash code. So hash function will generate hash code. There will be some hash code value. Okay. So on the basis of key, we are getting hash code. And with this hash code, we are getting the bucket index. Okay. So we got the bucket index, and in that bucket index, the entry will get stored. Entry means key and value pair. Key and value pair. So let's say, for example, bucket on the basis of hash code, bucket key is 7. Okay. So in the bucket 7 key and value pair that we call it as entry will get stored. Okay, this is like first iteration. Now again we are inserting some another key value pair, and for key 2 also hash code generated and it given hash code value, and for the same hash code again the same bucket index is came, then in that case it will also go in the same bucket, means key value pair will go in the same bucket. So how it will get stored? It will stored in the form of linked list. Okay, so first entry is stored in the bucket 7. Okay, and again we are trying to add one more key value pair, again new entry. For that also bucket index scheme is same, then the new entry is stored in the same bucket, but it is stored in the form of linked list. So likewise, if multiple entries are we are storing, and for those entries the bucket index are coming same, then those entries will get stored in the form of linked list. Okay, and suppose it keeps on adding, linked list size is increasing, then after reaching some threshold value, this linked list will automatically convert into the red black tree, which is self-balanced binary tree. So after Java 8 and later, linked list get converted into red black tree. So that is the internal working of HashMap. Okay, so we should understand this as how the key is being used to generate hash code, and how through hash code bucket index we are getting, and with the help of bucket index that entry is getting stored, and for multiple entries the same bucket index are coming, then those entries are getting stored in the form of linked list in the same bucket. And if linked list size grows, then it will convert into red black tree. So multiple entries are going in the same bucket, right? And then it is stored in the form of linked list. So we call this terminology in which multiple entries are going in the same bucket. That means we call this terminology as hash collision. Hash collision. Why? Because for multiple entry hash code are generated, but those hash code are referring to same bucket and collision are happening. That's why we call this terminology as hash collision. Multiple entries in the same bucket. And that's why those multiple entries are stored in the form of linked list, and later that is converted into red black tree. So in the most of the interview question they will ask you hash collision, what is hash collision, what is hash code, what is equals method, and how the linked list is getting converted into red black tree. What is red black tree? Okay, red black tree is what? It is self-balanced binary tree. That means the larger element will go on the right node and the smaller element will come on the left node. So this is the internal working of HashMap. Okay, so HashMap calculates the hash code of the key, determines the bucket index, stores the key value pair in that bucket. Okay, this mechanism enables very fast retrieval. Retrieval means getting an element with this mechanism is very fast. That's why HashMap is faster in performance. This is one of the reason, and another reason is the non-synchronized. Okay, so let's look at the time complexity for different methods we use in HashMap. So most HashMap operations execute constant time on average. Okay, that's why O of 1 complexity for different operation, put for adding an element, get for fetching an element, that is retrieval, remove is for removing an element, and containsKey, that is it returns a boolean value validating that key is existing in the HashMap. So it is one of the fastest data structure, okay, for searching and inserting data. So we are using searching means what? Get method. Inserting means what? Put method. It is giving what? O of 1, constant time performance. So it is faster data structure if you want to use insertion and searching operations. Okay, so let's look at some of the advantages of HashMap. Okay, what we are learning HashMap. Okay, so HashMap advantages are fast lookup, efficient insertion using put method, efficient deletion, remove method, easy key based searching. Okay, key based searching means containsKey. Support null values. Null values, we can add n number of null values, but only one null key is allowed in the HashMap. We have seen in the examples, and it is widely used in the Java application. Okay, so these are the advantages. Okay, HashMap is preferred whenever quick key based access is required. So on the basis of key, you want to get the access very fast, then we'll go for HashMap. Okay. Now let's look at some of the limitations. So it does not maintain the order of insertion. Okay, the order in which we are inserting the entry, that is key and value pair, those will not be maintained. No sorting. We cannot sort in the ascending and descending order in the HashMap. Okay, random sorting will be there. Duplicate keys are not allowed. Only one null key is allowed. It is not thread safe. That is unsynchronized. It is non-synchronized. Okay. Non-synchronized, that means thread unsafe. Thread unsafe means faster in performance. Okay. So we will see some real life examples. So whatever object, whatever data we want to store in the database, and we want it to be stored in the form of key and value pair. Okay, and key can be any data type, it can be integer, but value can be object. Okay, object means we can have custom class object. That means it can be, we can create our own class. Let's say class student. Okay, and inside that student we can define our property and behavior based on our requirement. So the key can be student ID. Okay, see, student ID, and value can be object, student object instead of student name. This is very simple scenario, but in real use case we will use student object. So like that we will define. So this will be key and value will be student object. That means student object means student can have not only name, student can have name, address, other details. Okay. Likewise, employee ID, see here it is written employee details. That means here we will be having employee. So value can be object, custom class object, product ID, product information, username, user profile, country code, country name. Country name is very simple, country details. Okay. So these are the real world examples. In many applications, they are using this concept for storing the data. Okay, using the HashMap. So let's quickly summarize what we have learned so far. So HashMap stores data in the form of key and value, and key should be unique, but values can be duplicate, and only one null key is allowed. Whereas we can insert n number of null values, multiple null values. We have seen in the examples. It does not remember the order of insertion. It does not maintain insertion order. Okay. Faster retrieval. Faster retrieval means faster fetching. We can get the element very fast. Why? Because it is using hashing algorithm, and also it is non-synchronized. That means thread unsafe. So faster in performance. And the time complexity for the operation like put, get, and containsKey is O of 1. That is constant time performance. So HashMap is faster in performance. So whenever the requirement is coming in which we want to get the element very quickly or faster in performance, we will choose HashMap as the collection. So that's all for this video. I hope this tutorial helped you understand the concept of HashMap in Java. Thanks for watching, and I will see you in the next video.